what I call full stack testing of cloud apps with Python. I admit it's not actually full stack. It doesn't consider unit tests because they are obviously and usually and all the time written in the same language that the actual production code is written in. So that's not to consider in this case. Also, there's a good reason to use Python on such a project. Not less because it's a language that any reasonable developer can understand, even contribute to the test environment and test stack. Usually front end is written in some kind of JavaScript, TypeScript or whatever. Backend, in this case, cloud apps, it's Java, Go, whatever, maybe even Python. So one of the advantages of using Python for the test stack is that it's a common binding language for everybody. Everybody can understand that. What is written there, what is being tested. And what is cloud app or software as a service? Obviously, in most cases, it's a web and a bunch of APIs, some databases and other black boxes that we don't want to consider. We sometimes have to, but usually don't have to. In the ideal case, or what is one of the purposes of tests, is to ensure that the APIs are at least somewhat, ideally, completely independent of each other. And what is interesting about most or a lot of the professional cloud apps is that what may be called the user interface is both the web and some of the APIs. You see a bunch of public APIs. GitHub has one, Facebook has one, everybody has one. And sorry for the Slovak. For those that don't understand English well, you can consider it as subtitles to what I'm saying. And what do we want to test? Basically everything. And ideally, or what I try to explain is how to piggyback on each of the phases of the testing so that they are related, connected, and built on each other. So some hard-earned principles. We had a lecture on BDD and BDT. I'm glad for it. I don't have to explain what BDD and Gherkin is. And what I consider the biggest advantage of a Gherkin test frontend is that you can understand what is being tested. Not that somebody on a cloud, somebody from business marketing or whatever will contribute. They never will. What you can mostly ask for and sometimes get an answer is clear requirements or somewhat clear requirements. They will never write Gherkin. The Gherkin or the Gherkin frontend is there for you because the code is mostly for reading. You read the code maybe 5 times more than you actually write one. And as it happens on medium, large or reasonably large projects, is that you get to read a bunch of code you wrote, probably didn't wrote it. If you wrote it 2 months ago, and without the BDD frontend, you can't understand what is being tested again. So another principle, I guess most of you work in Agile-like or Scrum-like Kanban-like environment is that these kind of tests, higher level than unit tests, have to be in the definition of done. So in the architecture I am trying to entail in my environment, in my company I work for, is that API tests should be part of any story, and end-to-end tests, the Selenium-like things, should be part of any larger stuff than is a story or epic, something which usually describes a complete feature. It's usually not impractical to write end-to-end tests or Selenium tests for something as small as stories, because obviously we try to make the stories as small as they can be. So, something about BDD again. I admit I didn't know there will be an explanation of BDD in detail before me. So for those that like mathematics, given when then is actually a translation of definition, theorem and proof. So you build for it, you have the definition of what the system looks like, then what the change is, and then the then step is the proof of what has to happen. So if anybody is thinking about why given, when, then, why this form, why not another, why there can't be any or whatever, if this happen, disconsider it and try something else. No, it's basically mathematics. It's basically mathematical proof. So about API services, the unit tests are not enough. We learned at heart. Usually unit tests are written by the same person who wrote the production code, which is a problem in itself. The problem is that you don't see the problems when you design the code, unless you use TDD. Who does TDD in this group? Test-driven development. Just about nobody. So unless you go by test-driven development, you can mostly disregard the unit test as useless. Also, one of the things that when you try to explain to developers that they should write higher level API tests is that, hey, we have API specification, API blueprint, and we have automated tools that will build the test around them. Well, these are not enough. These just test, okay, this endpoint is listening. Okay, this endpoint is giving me something that's reasonable form, it looks alright, so whatever. So API tests in this lecture, in this definition, are tests that use multiple endpoints from the same API or from the same service and try to build something that actually makes sense to the end user of the service, such as well, you may have to create a user. Okay, you will send an email password that was chosen by the user. Then you have to send a confirmation. Okay, this has a valid credit card. Then you send something else, 3 other things, and what you get on the outside is an identifier of a real user that was created in the API or in the service. And then the API test builds on that and tries to do something else. So what is the principle or the agile way to start building a API test suite? I call it the MVP approach. For those that don't know this thing, is the minimum viable product, and it starts with simple things. Usually, when MVP is explained, it's like, well, you want to build a device that can take you faster than by walking from point A to point B. Obviously, you don't start building a car. You will start building a kick bike, maybe even a bike, and then a moped, and then maybe a car. So you start small. And when you want to get developers to finally, in the end, write real API tests, you will explain to them something like I write right here. It's almost or pretty much the same complexity, pretty much the same work to write an example in Python request library that will use your new endpoint. That way you don't have to ask them as a tester, how does that endpoint work? You just run the example over and over again. Then you start, as you have these examples, you start building scripts around them. Okay, use this example to create a user, then get the user, put it to another example that will do some stuff about it, then to another. Chain them by scripts. Then the developers themselves will see that they are repeating the same code over and over again. So what some of the more intelligent of them will do is write something like an example client, something that will store the user for later use, something that will wrap the API calls to methods in a class. And for the consumers of the API, they can just send it to them in pure Python, and they will know what to build their code around. And then finally, when all this is done, and developers are used to writing something that will actually use their API as code, you can explain to them then, hey, just wrap it to PyTest or whatever. Something that I learned hard is that I actually missed the last part, and that is the BDD or behavior-driven front-end to the API tests. Because what you will end up with in this case is a bunch of code in PyTest or whatever, and it will be just a method after method, code after each other. And well, you can watch if it's properly documented, if every call to the API is there for some reason. But if you have a code that's properly documented with all the comments around the code, it's very close to BDD actually. And then when you have the front end, you can just easily look, hey, it's doing this thing. It's just obvious. So when you have the thing I was talking about in the previous slide, the examples or a client or API tests or whatever, using the locust thing is easy as pie. You will just reuse the code, write tasks, and then locust provides all the other things. It creates clients, it creates reports for you, it handles the parallelization, it handles many requests in the same time. It even has something like a ramp up, so you don't end up with 10,000 requests at once, but going from 10 to 100 and so on. So yes, it all adds up to the whole set. And then, but maybe in a parallel fashion, you will step up to end-to-end tests, which, well, in an environment like where I work, I write and lead a team of several people that write tests for 4 different products written in 4 different front-end libraries. You just end up in Selenium. Nothing better exists that can handle anything you throw at it. And then, if you have the support from the developers and the API test, example plans and such, you can use the API as well. First of all, API calls are many times faster than clicking something in the web. Second, they are much more reliable. So in the end, you will probably end up in a structure like is outlined in the last point, and that is that the whole test setup, the given step, is done by API calls. Then, when everything is set up, you will do some clicking in the front end, in the web, and then you verify everything either through the web, if it makes sense, probably more via the API, if it's all correct. So in this fashion, you should end up with tests that are ideally under 1 minute of runtime. So yeah, you do 4 clicks in the web, and the rest is API calls, which are usually pretty fast, which was already verified by the Office test, by the way. So I was asked to be pretty fast. So if you want more of this and want to dig into any kind of testing further, there's testing out conference, maybe 2 times a year. If you are more into unit testing and want to practice test-driven development, code design and stuff, come to Code Retreat. I guess there's no better option to learn how to write proper code. And one thing for those that want to use Behave, there's a problem with Behave. It has a variant. First of all, Behave is not maintained from 2014 on, so for 5 years already. There are forks. One of them is Behave Parallel, which can run tests in parallel. Pure Behave cannot. And there's another fork of the Behave Parallel fork that can actually work with Python 3. This that's the link I added there, and it's tested. We switched to Python 3 like 3 weeks ago, and it seems to still work. So if you have any questions. No.